Good evening, guys. And today is the last part of the chapter number 1 of the Kaplan Preclinical Pharmacology. These are the pharmacokinetic principles, and you just need to remember these formulas, and you need to know that where to use them, and you need to have information about the necessary use of them in the examination. So, there are two kinds of formulas or equations. First is the single dose equation, and the second is the multiple dose or infusion rate equations. In the single dose equation, the first formula is for the volume of distribution Vd is equal to d by C naught. What is d? It is the dose, and C naught is the concentration of the drug at the time zero. So volume of distribution, what is volume of distribution? Volume of distribution is the volume in which the drug is present in the tissues and the drug has been distributed. Okay, the drug has been distributed and it is not present in the circulation. So Vd is equal to dose divided by concentration of the drug at the zero time. Next is the formula for the half-life. It is T1 by 2. We indicate the half-life as T1 by 2 and is equal to 0.7 into volume of distribution divided by the renal clearance. In this formula, you can appreciate that the half-life is directly proportional to the volume of distribution. It means that when the drug is present in the tissues, it means that the volume of distribution of the drug is high, the half-life of the drug would be high. And if the renal clearance is high, that means that the drug is eliminated from the body. It is being eliminated by the kidneys. So it means that half-life of the drug would be less. So half-life is equal to zero point 0.7 into Vd by renal clearance. Let's talk about the multiple dose or infusion rate equations. There are three. First is the infusion rate. Okay. Infusion rate is equal to clearance, renal clearance multiplied by the concentration of the drug at the steady state. We have discussed the steady state in detail in the previous lectures. You can go through them as well. Infusion rate is indicated as K0 or K0 is equal to the clearance multiplied by the concentration of the drug at the steady state. You just need to remember these formulas and you need to know their function, or when some values are given and the others you need to calculate them. Second is the loading dose. What is loading dose? Loading dose is the amount of the drug that is given one time to maintain a clinical steady state, to maintain a certain plasma level. For example, if the patient is suffering from the dangerous arrhythmias, we administer the patient digoxin. But do we need to administer the patient maintenance dose, or do we need to give in an emergency situation a loading dose? In emergency situation, we need to give the patient a loading dose. It is a one-time dose and it's very high, about twice the time as maintenance dose. The formula is the volume of distribution multiplied by concentration of the drug in the plasma divided by the bioavailability. And if the drug is administered IV intravenously, so volume of distribution, concentration in the plasma, and bioavailability would be 1, because intravenously there is the bypass of the first pass metabolism and the bioavailability for such drugs would be 1. Loading dose is Vd multiplied by Cp divided by F. And what about maintenance dose? Maintenance dose has some formula related to the infusion rate. Okay, we put the formula for the infusion rate: clearance multiplied by the concentration of the drug at the steady state multiplied by tau. Tau is the dosing interval. For example, we are administering dose 4 hours apart, so dosing interval would be 4 hours and divided by bioavailability. And again, if the drug is administered IV, so the bioavailability for such drug would be 1. One more thing here worth mentioning is that in the maintenance dose, because we are giving the drug frequently, right? We are giving that drug frequently after each dosing interval. So we need to keep in mind that what kidneys are doing to our drug. We need to keep in mind the renal clearance, okay? In maintenance dose, that's why renal clearance is very important because we are giving such drugs frequently. So what kidneys are doing, what is the function of kidneys on that particular drug, we need to keep in mind that thing. But in case of loading dose is given one time, okay, and in such cases renal clearance is not of such importance, and we do not consider renal clearance in case of the loading dose. And this sum up our first chapter of preclinical Kaplan pharmacology, and that was for today. I will see you in the next video with the next chapter, and that is pharmacodynamics principles. So take care till then. Goodbye.